Hello everyone, I am Swaminathan, Assistant Professor, Department of Mathematics, SRS College of Technology, Coimbatore. Hello all, today we are going to discuss about the vector calculus. First we have to see the scalar quantity. A scalar quantity is that which has magnitude and not related to any direction. That means which is represented as a magnitude. Next we have to see the vector quantity. Vector quantity describes magnitude and direction. The next definition is scalar point function. If a corresponding point P, that is a scalar denoted by pi, so corresponding point is denoted as P. Therefore pi of P is said to be a scalar point function. For example, the temperature at any point occupy a certain region is a scalar point function. The next definition is the vector point function. The f is denoted as vectors, so the corresponding point P is, that is f of P is said to be vector point function for the region R. For example, acceleration f of P of the particle at any time occupy the certain position P, which means the article moment of article describes, so which is called the vector point function. Next we have to see the vector differential operator. The vector differential operator del is defined as del equal to I into dou by dou x plus j vector into dou by dou y plus k vector into dou by dou z, that is equivalent to summation of I into dou by dou x. Next we have to see the topic is gradient. The gradient of scalar point function. Let pi of x comma y comma z be a scalar point function and is continuously differentiable, then the vector del dot pi is describes as pi vector I into I vector into dou by dou x plus j vector into dou by dou y plus k vector into dou by dou z of pi, which is equivalent to I vector into dou pi by dou x plus j vector into dou pi by dou y plus k vector into dou pi by dou z, which is called the gradient of pi. It is written as grade pi, that is grade pi is equivalent to del pi, which is called the gradient of pi. Del pi defined as a vector field. Del pi is not equivalent to pi into del, which is the two important notes. So next we have to see the properties of gradient. The first property of gradient is if f and g are two scalar point function, then del of f plus or minus g is equivalent to del f plus or minus del g, or gradient of f plus or minus g is equivalent to the gradient of f plus or minus gradient of g. The second property is if f and g are two scalar point function, then del of f g is equivalent to f into del g plus g into del f, that is gradient of f into g is equivalent to f into gradient of g plus g into grade f. The third property is if f and g are two scalar point function, then del of f divided by g is equivalent to g of del f, g into del f minus f into del g divided by g square, where g is not equivalent to 0. The fourth property is gradient of constant is 0, that is del pi is equivalent to 0. Let us see the one example problems. for the question is find grade pi where pi equal to x squared plus y squared plus z squared. Solution: del pi is written as, that is the formula, gradient of pi is I vector into dou pi by dou x plus j vector into dou pi by dou y plus k vector into dou pi by dou z. So I vector into dou by dou x of pi value is x squared y squared plus z squared. Therefore, differentiate the first term dou by dou x of x squared plus y squared plus z squared. The remaining y squared z squared are constant value is tends to 0. Therefore, dou by dou x of x squared is 2x. Therefore, I into 2x plus j into differentiate second term with respect to differentiate second term with respect to y. Therefore, dou by dou y of y squared is 2y, and in this third term k vector into dou by dou z of z square is 2z. Remaining are constant value is 0. Therefore, del dot pi equal to 2x I vector plus 2y j vector plus 2z k vector. So next example, find grade pi if pi equal to xyz at 1 comma 1 comma 1. From in this proof, the solution is we have to find del pi, then we have to apply the points 1 comma 1 comma 1 instant of x comma y comma z. So the solution of del pi is I into yz plus j into xz plus k into xy. Therefore, del pi at the point 1 comma 1 comma 1, which is equal to, substitute xyz as 1 comma 1 comma 1. So the conclusion is I vector plus j vector plus k vector. Similarly, we have to prove the third example. Further, we have to see the next topic in this. It will be next video. Thank you.